So now let's move into examining the presented solutions from both Vertex Pharmaceuticals and Sana Biotechnology. Okay, we're going to start with the science of it all. What are these newest breakthroughs and what do they offer us? Artificially enhanced beta cell stability. We want beta cells that aren't going to get knocked off by the immune system. So Sana has introduced these immunoevasive beta cells that implant, produce insulin, and have a bunch of cellular mechanisms along the way that help cloak it and enclose it from the immune system so that they can persist. Vertex, another means of implanting healthy beta cells that can actually stay in the pancreas and become responsive to blood sugar levels in a way that helps regulate them. Vertex requires immunosuppressants because it does not have that protection measure that Sana does. Both have led to stabilized blood sugars requiring little to no exogenous insulin after an incubation period. Some of them were 6 months. There was a year follow-up, I think was the big mark of success in the recent disclosures of the progress being made. So it's exciting, right? Because we're ultimately being given that thing we wanted the most, which was beta cells that make insulin. So let's take a little bit closer look at what Sana Biotechnology is all about. It's using something called hypoimmune technology, HIP, hypoimmune technology. And this is a tested immune evasion technology. It's a way for it to avoid being detected by the immune system. So it's a stem cell derived therapy as a one-time treatment for patients with type 1 diabetes with a goal of normal blood glucose, no insulin, and no immunosuppression, right? All those things check some pretty big boxes for those with diabetes, right? And this is all from the Sana Biotechnology website, by the way. Now, this they don't talk a whole lot about on the Sana Biotechnology, but I did some deep dive into how this HIP technology works. And it does it via two main mechanisms. So removing HLA expression and overexpressing CD47. So HLA, if you are at all familiar with my channel, I've talked about it before, human leukocyte antigen gene complexes. It's got ties to diabetes development. It has a lot to do with our immune system's ability to recognize friend from foe, right? These are like the policemen that go around plugging into cells and making sure, hey, do you belong here? Hey, do you belong here? No, I'm activating the immune system, getting rid of you. So these beta cells from Sana don't have a plug. They are genetically modified to delete these particular classes and portals that our immune system interacts with in cells to activate the immune system, right? It blunts T cells' ability to recognize these beta cells. So it's kind of like blocks them, you can't touch me, closed off. And then with this CD47, cells can express a don't eat me message, like, hey, back off, I'm safe. It cloaks me, right? We want to make sure that we're covering from both sides of the coin. One coin is saying like, hey, listen, I'm going to make sure that these implanted beta cells don't present anything to the immune system for them to attack me. Not only that, but I'm putting out a signal that says, like, leave me alone, don't interact. don't eat me, right? This is preventing cellular, like intracellular things from cleaning it out and getting rid of it. So think about this. Sana biotechnology has a beta cell that is camouflaged, right? It blends in. It's not presenting antigens. It's like, oh yeah, I'm good, I'm safe. The immune system, not going to be detected. I put out CD47. This is saying I'm safe. Not only can you not engage with me, don't even worry that I'm here. Totally safe. You don't need to worry about me. Now let's think about this on kind of a little bit more of a systemic scale. This solution operates under the assumption that beta cell destruction is immune initiated. This assumes that nothing outside of just the immune system acting on beta cells incorrectly is why type 1 diabetes happens in the first place. Is that okay? Do we think that there are other things at play in the development of diabetes beyond just immune initiation? I sure do. Right? What about the nutritional side of cellular health? Things like the liver, the gut, the brain, the nervous system, pathogen exposure. Might these have an effect on beta cells? Yes, absolutely. Absolutely, they do. And I would argue that it was those things, the nutrition and the liver health, gut health, nervous system, that disrupted the beta cells enough in the first place to get the immune system involved. So the immune system is secondary to cellular health. And this kind of voids that and is just like, well, we're going to take care of the immune system so whatever beta cells we implant can survive. Questionable. And also, the immune system plays an important role in normal healthy cells, cleaning healthy cells, protecting them from outside pathogens. When a cell goes through a regular life cycle, it ages just like anything else. So when cells age, they become senescent. They become engaged with the immune system that help clean them out and allow for a new cell cycle. Is that going to be impacted by being completely camouflaged and saying everything's safe? What if we have an old cell that needs to be engaged and can't? Just food for thought. And then the next thing, this really caught me off guard and is something that I will expand upon in another video. But when you think about the characteristics I just mentioned, the decreased HLA expression and the increased CD47 expression, I've heard of both of these things before. What other cell types are masters of disguise in evading immune detection? And it just so happens to be through these exact metrics. Decreasing HLA presentation, right? Not creating antigens so that our immune system can engage, and also overproducing CD47 so that the body thinks it's safe and it can just do what it wants to. Think about it. What cells go undetected for too long before they become a problem? Cancer cells. Cancer cells thrive using these same exact mechanisms that we're employing in getting these beta cells to survive. Now, there's some nuance in the Sana technology, but they're not talking about this. They are not talking about this, and there are definitely things that we need to be talking about, because If you were to Google CD47 or HLA and cancer cells, thousands of papers. These are just a few, but you can see here in the bottom, HLA class molecules are key in tumor recognition and T cell mediated elimination. Loss of HLA class expression results in reduced antigen presentation and facilitates cancer immune evasion. So this is like weird. This is really weird to me that we're kind of borrowing cell mechanisms from cancer that cancer uses to proliferate and survive in the body, and using them in beta cells. We need to know more. We need way more details, right? So how is a beta cell that is designed to evade the immune system being cleaned and maintained in a way that allows the cell to flourish and proliferate, right? Some things are handled internally by the cell without involving the immune system. Redox clearance, ROS loads, senescent cells, cell turnover. These are all things tied to the nutrition aspect of things, our liver's ability to clear things out. Those need to be taken care of from a diet and lifestyle standpoint. And if anything were to go wrong within beta cells, the immune system comes in, disposes of what needs to get disposed of so that everything else can return to normal. Are we making those secondary efforts to ensure proper nutrient supply? Whether it be, regulating calcium, magnesium, potassium balance, and mitochondrial iron management. Because if we don't address those things, the cell isn't able to sustain itself from the inside, and it would need the immune system to come in and get rid of those damaged beta cells. So the immune system is a necessary component of healthy cell and tissue maintenance. And how are these components being controlled for in the Sana BioTech answers, right? Because, yeah, they're healthy beta cells now, but how are they being fed in our body? Like, it's not just like an infinite battery. I don't, there's a huge thing to be addressed. And I asked this question and dove a little bit deeper into, okay, well, beta cells have a life cycle. That, it's not like, oh, I have one beta cell and it lasts forever until the immune system kills. It's like, no, beta cells have shelf lives. And how are they being cycled through without immune interaction? That's impossible. So HIP technology frequently employs an anti-CD47 to remove the quote-unquote cloaking mechanism to submit the cells to immune detection. So the same things that made those beta cells sustainable, right? And they did this in the trial themselves. If a cell expresses a lot of CD47, it's not going to be acted upon. What happens if a beta cell malfunctions, right? Sana Biotechnology protected itself and was like, hey, okay, if CD47 is what is kind of creating that cloak of invisibility, we're going to inject anti-CD47 to eliminate that invisibility cloak, and then the immune system comes in and cleans things out. So in those Sana trials, if a cell line stopped functioning, the anti-CD47 exposed the implanted cells and the immune system removed them. This is good for safety, right? If something goes awry and it's producing at these high rates, but with no way of regulating it, it's good for safety because we need to be able to, whoa, stop. But it's bad for longevity. Because if a healthy beta cell typically lives anywhere from 20 to 50 days, depending on how healthy that environment is, how are we dealing with cell turnover and cell reproduction? Are these implanted beta cells able to go through a typical life cycle, because a typical life cycle requires immune intervention, but they're cloaked from the immune system. So how is an aged beta cell being removed so that a new beta cell can take its place? And this is where it's like, oh, this isn't forever. I might need more than one injection, right? Because it's being sold as a one-time procedure. But CD47 blockade, taking in the anti-CD47 leads to global clearance of all of the cells. So it's not like, oh, one of the implanted beta cells is not doing something right. Can we basically remove the cloak from just one? No, it's everything. So if you get a full injection of good beta cells and one goes wrong that you need to take care of, and you take that anti-CD47, everything gets wiped out. So this would mean starting the entire islet replacement cycle all over again. So new implanted cells. There's no current way to selectively uncloak only dysfunctional subsets of HIP cells, all or nothing. That's not something that they're talking about. Something we need to be talking about. All right, so let's move on to Vertex Pharmaceuticals. They're using an islet cell therapy. They're implanting healthy beta cells. They called it Zimislocel. It is a beta cell replacement therapy that restores insulin production, regulates blood sugar, and allows insulin independence for most participants. Now, it does not have the immuno-evading technology that Sana does, which, based on what we just learned, might be a good thing. But then that means that it's going to rely on immunosuppression, which introduces its own risks and side effects. So it offers a functional cure at the cellular level in terms of, hey, you've got beta cells that make insulin, but not a cure for the immune or metabolic causes of type 1 diabetes. So this is from the New England Journal of Medicine's report on Vertex's trials. They did it on 12 patients. Of those 12 that reported, 10 became insulin independent after 1 year. So that's about 85% success rate. 92% reduction in insulin use across all 12. Most had an A1C under 7%. Those are all good things, right? I mean, 85% success rate, that's good. A lot less insulin regulated A1Cs. Cool. But we need to be told this, and we need to make sure that we're acknowledging what we're learning. So imperfect results, 85%. What made the 2 of those 12? What made the 2 patients that didn't become insulin independent not become insulin independent, right? What are those compounding variables? We need to talk about lifelong immunosuppression and its associated risks, because guess what? Lifelong immunosuppression comes with, you guessed it, the big C word, right? Because immunosuppression means that we're decreasing sensitivity to things like HLA, which is how the immune system acts on things that need to be taken care of. So you have an increased risk of infections. You have an increased cancer risk. Some regimens are directly genotoxic in terms of like altering DNA and causing cancer expression, while others foster tumor permissive environments like the decreased HLA expression. So there's a whole can of worms that nobody is talking about. And then metabolic dysregulation, right? These increased cardiovascular risks and compound pre-existing metabolic issues, especially for those with type 1 diabetes, right? Nobody just has diabetes. You have liver troubles, kidney troubles, nervous system troubles, you name it. If you don't have an immune system working at full throttle, just for the sake of beta cells, what else are you being compromised in? And what does that mean for your reliance on the healthcare system, which was one aspect of our updated goal? So this lack of systemic context to maintain the health of implanted beta cells is the root, right? How can we eat normally? What does normally mean? How do we supply the nutrients that these beta cells need to survive and thrive and sustain? So here's just a quick little summary page here. I'll get my face out of the way. What we're being sold, right? Hey, this one's on the pamphlet, Vertex and Sana. You're off insulin, you get your health freedom back, and you're normal, just like everyone else. Hooray. What's not being said? In case of Vertex, lifelong immunosuppressant use and the risks, right? Which they don't talk about. It's unclear what the side effects of long-term immunosuppression are. Sana, the metabolic impacts of insulin production from an immunoevasive cell. Is this really a one-time procedure? Or again, are we putting on auto subscription again, where we're going to need to keep going back every time those beta cells need to turn over? And unclear about long-term impacts of tumor-related therapeutic mechanisms, specifically decreased HLA expression and increased CD47 expression. Both of them depend on the autoimmune origin theory of type 1 diabetes to be correct, because none of them are addressing cell-based environment, dietary, or lifestyle factors. What is making these beta cells run? Are they managing iron? Do they have enough magnesium, potassium, calcium to operate properly? Is anything being done to address those things? The answer is no. And so it brings us back to the question, is this just like a really shiny new way to symptom management? Or are we actually addressing a problem? Because again, blood sugar is good, regulated. I get to eat what I want. Do we have any way of preventing the issue from happening again? Nope. You might even have to come back for a new thing that you get after being on immunosuppressants for so long.